related to banking of the road. So first problem is that for traffic moving at 60 km per hour along a circular track of radius 0.1 km, the correct angle of banking will be. So as we know that the angle of banking will be tan theta and it is equal to V square by RG. So V is given equal to, first V is given equal to 60 km per hour, and it is 60 into 5 by 18 meter per second. So 10 into 3, 50 by 3 meter per second, and R is equal to 0.1 kilometer, that is equal to 100 meter. So if you put the value of all these terms, then tan theta is equal to 50 by 3 whole square divided by 100 into Gg is 9.8, and theta is equal to tan inverse 50 by 3 whole square divided by 100 into 9.8. So this is our answer, and if you see the options, then answer is B. Now we will see next problem, and the problem is that a vehicle is moving with a velocity v on a curved road with width b and radius of curvature equal to r. For counteracting the centrifugal force on the vehicle, the difference in elevation required in between the outer and inner edge. So basically you have to calculate the difference in angle, difference in elevation in outer and inner edge. So basically you have to calculate the height h. This is the inner edge, this is the inner edge, this is our height, and this is our outer edge. So you have to calculate the difference in elevation. So as we know that if this is our length L, and it is given that the velocity of vehicle will be v, so v is the velocity, the width is given as equal to b. So as we have already learned that b is approximately equal to L, and the formula was tan theta is equal to v square by rg is equal to h by L, and L was written as equal to h by b, so approximately equal to h by b. So tan theta is equal to v square by rg is equal to h by b. Now so you have to calculate the value of h. So h is equal to v square b by rg. So if you see the options, then first option A satisfied, and the answer will be v square b by rg, or option A. So now we will move to our next problem, and the next problem says that the radius of curvature of a road at certain turn is 50 meters. So r is equal to, given as equal to 50 meter, the width of road is equal to 10 meters. So b is given as 10 meter, the outer edge is 1.5 m higher than the inner edge. So h is also given equal to 1.5. you have to calculate the safe speed. So as we know that v square by rg is equal to tan theta, and it's equal to h by L, and it is approximately equal to h by b. So h by b is equal to v square by rg. So if you have to solve its value, then a v is equal to a square root rg h by b, and we just put the value that h is equal to 1.5, r is equal to 50, g is equal to 10 divided by b is equal to 10. So it's a square root 75. So it's something equal between 10 and 9. So the answer with 10 and 9 is equal to 8.6. answer will be 8.6. So if now we will learn next problem. The distance between two rails is 1.5 meter. The center of gravity of train is at height of 2 meters from the ground, the maximum speed of the train on a circular path of radius 120 meter can be given by. So as we have already learned that when a train moves in a circular path, or when a body moves in a circular path, and if center of gravity is at h height from the flat road, and if the distance between rails is equal to 2a, then the maximum speed of a car without overturning on a flat road is given by v is equal to square root gra by h, where h is the height of center of gravity from the road, and 2a is the distance between two rails. So here 2 is equal to 1.5 meter and a is equal to 1.5 divided by 2, or 0.75 meter, and r is equal to 120 meter. So if I put the value of all those terms, then from there we get v max is equal to the square root gra divided by h, and value of g is 10, value of r is 120, and a is equal to 0.75 divided by 2. So the value comes equal to approximately equal to, if you solve it, then just take 10 outside, 6 into 0.75, and it's equal to 10 into square root 4.5, so approximately equal to 21 meter per second. So answer will be C, 21 meter per second. Now this is a problem from AFMC 1988, and the problem is that a car sometimes overturns while taking a turn. When it overturns, it is the inner wheel which leaves the ground first, the outer wheel which leaves the ground first. Either wheel leaves the ground first, and both the wheels leaves the ground simultaneously. So whatever we have learned that the reaction force on inner wheel is given by, if you can recall the formula which we just derived some slides back, then r1 is equal to m by 2 g minus v square h divided by ra, and r2 is equal to m by 2 g plus v square h divided by ra. So clearly r1 will be 0 when this term inside the bracket will be 0, or g minus v square h divided by ra is equal to 0, and where v square is equal to gra divided by h. So this is the formula with which we just solved our previous problem, that is when v is equal to square root gra divided by h, then the inner wheel leaves the ground. So basically the inner wheel leaves the ground first when the car overturns while taking a turn on a circular path. So afterwards we will move to our next problem, and this is in fact a very good problem, that if a train A runs from east to west and another train B runs on the same mass, runs from west to east at the same speed along the equator. A passes the track with the force F1 and B passes the track with the force F2. Then you have to calculate the relationship between F1 and F2. So basically, if you see that this is the earth, and on which we have a track and the train is passing on this track. So now this is the center of earth towards which the centripetal acceleration acts, as well as mg acts. So mg acts towards the center of earth, as well as centripetal acceleration mv square by r acts toward it. It's the normal reaction force acts upward or outward to the wheel. So if I draw the figure here, Then this is our train which is moving on the level road, and it is, as it is moving, then mg will act towards the earth. mv square by r is equal towards the earth, and this reaction force r will be in upward direction or opposite to mg. Now based on this concept, we also know that earth revolves around earth, in fact rotates on its axis from west to east. So if I consider the angular velocity of earth be omega e, and angular velocity of the strain equal to omega t, then for train B we have both earth and train moves in the same direction, that is from west to east, and the net angular speed of this system will be equal to omega e plus omega t. However, for the train A, as the train A moves in from east to west, so for this the net angular speed will be omega e minus omega t. Now we will apply the Newton law of motion, which says that Newton, in fact, second law. So it says that summation f external is equal to ma. So how we will write the force diagram or the free body diagram? For this, always take the direction of acceleration as a positive, and the force corresponding to the direction of acceleration will be taken as positive, as well as force opposite to the direction of acceleration will be taken as negative. So for train B, we have acceleration is equal to m omega e plus omega t whole square into r. So as we know that this force, centripetal force, will be mv square by r, or it may also be written as m omega square r. So if you see that this is our centripetal acceleration, in fact this is our centripetal force. So now we will take this direction will be positive, and this is towards the center, so we will take the force towards the center with a positive sign, and the force opposite to the center will be negative sign. So this is our basically equation, and if you solve this equation, then the value of r comes equal to mg minus m omega e plus omega t whole square into r. So this is our reaction, this is the radius of earth. So this is our equation first. Now this is for train B. For train A, if I write the similar equation, then for train A we get that mg minus r is equal to m omega e minus omega t square into r, and finally it will be equal to r is equal to mg minus m omega e minus omega t whole square into r. So this is our equation 2. Now if you see the problem, that A presses the track with a force F1, so basically r is equal to F2, and this for train A it's F1. So if you see the equation, then clearly that it's very clear that this is a smaller quantity, and F1 must be greater than F2. So F1 is greater than F2, as F1 is associated with a smaller term with negative sign, and F2 will be associated with a bigger term with negative sign. So clearly F1 will be F2 greater than F2, and the answer will be A. Now we will